A strange awakening occurred in the outer reaches of our solar system, an event so counterintuitive that it should have been impossible. A colossal comet, roughly the size of a small metropolitan area, suddenly became active near the orbit of Saturn. At that distance from the Sun, nothing should be stirring. Temperatures plunged to around -150 degrees Celsius, cold enough for water ice to remain solid and unchanged for millions of years. Under these frigid, dim conditions, comets are expected to remain silent and inert, locked in deep freeze as they drift through the darkness. And yet, inexplicably, this object began releasing gas as though it were nearing the warmth of the inner solar system. Astronomers took note of the anomaly, logged their observations, and proceeded with other research, treating the event as another odd data point among many. Then, something even stranger happened. A smaller object entered our solar system, this one originating from interstellar space. And suddenly, the clearest, highest contrast images of these visitors were not coming from NASA or major observatories. Instead, they emerged from consumer-grade equipment, telescopes and cameras that anyone could purchase online. What these independent observers found did not line up with the neat, measured narratives offered by institutional astronomy. One astronomer, commenting on an institutional release, admitted disappointment. The official image was smeared, jittery, and lacking meaningful clarity. By contrast, Hubble's earlier imagery had shown far more structure, suggesting that something in the recent data pipeline was off, or perhaps intentionally subdued. For 8 consecutive years, astronomers have watched unexpected visitors arrive, objects behaving in ways that defy established models. Oumuamua accelerated as though pushed by invisible jets of gas, though none could be detected. Borisov behaved more like a traditional comet, yet with unusual compositions. Now, in 2025, 3I-ATL displays structural complexity in amateur photographs that barely registers in the sanitized previews from institutional sources. Individually, each anomaly is puzzling. Together, they begin to form a pattern, one that becomes increasingly unsettling when independent observers processing data on home computers produce clearer, sharper, and more revealing images than billion-dollar instruments. This raises one of the most important questions in modern astronomical research. How is it possible that backyard telescopes routinely deliver more informative imagery to the public than the heavily funded mission-calibrated spacecraft and observatories designed for deep space detection? An interviewer tried to reassure the public, stating that better data would soon arrive as the object approached Earth. But that reassurance only highlights the deeper puzzle. Why must we wait for official confirmation when an entire global community of independent astronomers is already releasing high-quality images in real time? To understand the larger picture, we need to revisit an object that slipped under the public radar. In 2014, observers detected an enormous body, designated 2014 UN 271, later named Bernardinelli-Bernstein. It spans an estimated 150 kilometers, 93 miles across, large enough that many scientists debated whether it should be classified as a comet, a dwarf planet, or something in between. More than 99% of main belt asteroids are smaller. This is a world, not a rock. And this is where physics begins to fail us. UN 271 displayed activity, real outgassing, at a distance of 9.2 astronomical units from the Sun, just inside Saturn's orbit. The sunlight there is 85 times weaker than the sunlight bathing Earth. Temperatures hover around -150 degrees Celsius, conditions under which water ice remains locked in place and carbon dioxide barely stirs. Despite these frigid, dim conditions, comets are expected to remain silent and inert, locked in deep freeze as they drift through the darkness. Despite this, astronomers detected significant emissions of ammonia, carbon monoxide, and carbon dioxide. A visible coma formed, something that should not happen in such deep cold. UN-271's size only compounds the mystery. Larger bodies tend to retain internal heat longer, but an object this old, formed billions of years ago in the Oort cloud, should have lost nearly all its primordial heat. It should be, in scientific terms, thermally exhausted. Yet here it is, waking up in a zone where no known mechanism should allow such activation. Perhaps the strangest part is the institutional reaction. The discovery made it into journals, the activity was acknowledged, but after that, silence. No dedicated press conferences, no sweeping explanations for the public, no deep dive into a phenomenon that upends long-standing models. Now, contrast this muted response with what independent observers have uncovered about 3I ATL. While official observatories released minimal, low-contrast previews, amateur astronomers took matters into their own hands. Using techniques like image stacking, combining hundreds of short exposures into a single ultra-clean composite, they produced visuals far superior to institutional releases. One observer in Chile used a 14-inch telescope and captured 240 frames in just 6 hours. The processed result revealed brightness gradients across the coma and hints of structural asymmetry. Another observer in Spain went further, compiling 159 images and detected a startling feature, a sharply defined narrow jet emerging from the comet's forward-facing hemisphere. Not a diffused solar-pushed tail, something different, something aligned with the object's direction of travel. This is not comet behavior as we understand it. Standard comet physics dictates that jets and tails always point away from the sun, sculpted by radiation pressure and the solar wind. Yet 3I ATL appears to be emitting a concentrated plume forward, as though venting material in the very direction it is moving. Its geometry remains stable across rotational cycles, implying that the jet originates from a fixed location on a solid nucleus. This would require internal structure and integrity far greater than typical comets possess.
Most importantly, this feature has been independently documented by multiple observers using different equipment on different continents. It is not an artifact, it is not noise, it is real. And yet, no major observatory has released imagery showing this jet clearly. No scientific agency has provided an official explanation. When pressed, institutions cite calibration issues, insufficient signal-to-noise ratio, or incomplete verification. But amateurs, with inferior instruments by every measurable standard, are producing images that effortlessly contradict those excuses. The question grows urgent. Why would institutional results appear deliberately muted? The answer likely lies in data release protocols more than hardware. Space agencies and major observatories undergo strict verification before making data public. Amateurs do not. They share their results immediately, without bureaucratic delay. Still, this does not explain why official processed images show less detail than amateur composites, unless certain features are intentionally downplayed. Now, widen the scope. For all of recorded history, humanity documented 0 confirmed interstellar visitors. Then, suddenly, in 2017, Oumuamua arrived, followed in 2019 by Borisov, and now, within a few more years, by 3I-Atlas. 3 interstellar objects in 8 years after millennia of nothing. Statistically, this does not resemble improved detection. It looks like a cluster of arrivals. Add the anomalous behavior of UN-271, and the pattern deepens. Some researchers speculate that our solar system might be passing through a denser region of the interstellar medium, increasing the number of inbound objects. That remains plausible. But an alternative interpretation exists, one that mainstream institutions hesitate to address. What if the objects themselves represent a genuine increase? What if their clustering is intentional, or at least not random? What if some are not natural at all? This is where institutional silence becomes problematic. When amateur telescopes reveal features that official observatories omit, it erodes trust. Not because the public is delusional or predisposed to conspiracy, but because anyone can compare the raw evidence. The disparity is obvious, the questions are reasonable. And as the window for observing 3I-Atlas closes and UN 271 slowly approaches, the world may forget these anomalies, but they will remain embedded in the data that independent observers are now more trusted to provide than agencies funded to explore the cosmos. Why are multiple anomalous visitors arriving in such a short time? Why do amateur astronomers consistently publish clearer images than billion-dollar systems? Why do institutions release low-detail previews when high-resolution internal data almost certainly exists? Why are explanations missing, delayed, or overly cautious? Perhaps nothing extraordinary is happening. Perhaps these are rare but natural variations in cosmic behavior. Yet even if that is the case, the underlying issue persists. Independent researchers are shaping our understanding of the solar system more effectively than established institutions. And if this trend continues, the next paradigm-shifting discovery may not come from NASA, ESA, or any major observatory. It may come from a backyard, a driveway, or a garage. Somewhere, an amateur astronomer points a telescope at the sky and captures something institutions chose not to show.